A very good day to Dr. Mahfudza. My name is Kiran Kaneswaran and my matrix number is 197810. Today I'm going to be explaining about question number 2 from tutorial 4. So question number 2 is a convolution question of signals xt and ht. So xt is equals to ut and ht as a range, piecewise function range. And now we can go into the question. Plot xt and ht. So at the beginning it's basic. Xt is a step function and ht is plotted through the piecewise function ranges, and then we have to use graphical method to help find yt. So in order to find yt using the graphical methods, we have to change ht and xt into h tau and x tau. So when we do that, x tau becomes this, and then h tau, we have to shift it so it becomes h negative tau. Once we are done with that, we go into the integral part in order to find yt. So we integrate for each of the cases, where case 1 is t is less than 0. So when t is less than 0, it's basically in negative range and we don't have anything there, because as you can see, x t is fully 0 and as well as ht minus tau. So we do this ht minus tau because we want to right shift it, right shift the function so that we get this. And after that, it is easy for us to look at the y. So when we do this, we can conclude that y is also 0. Since t is less than 0, there's no necessary for the integration. Then we come down to case number 2, which is 0 is less or equals to t is less or equals to t. So in here, x tau is still the same and ht minus tau is also still the same. But now we have to do an integration because we do have a range of values. So we do the integration regarding 0 to t. So since xt is equals to ut, substitute xt as ut inside here. So ut times ht differentiated by tau, d tau. So it becomes 0 to t minus tau, because ht is equals to t minus tau in that range, right? As we have shifted. So once we have done that, when we integrate it, we get t square minus t square over 2, which the final answer will be t square over 2. So since it's a square, it will be a parabolic like this. Alright, and it's from 0 until t over 2 because of the range given. And now we go to case 3, which is t is more or equals to t. So we do the same thing, x tau and ht minus tau. And just as same as the case 1, we don't actually have a number, a physical number there, just a constant. So we don't have to do the integration. It's just that we take the line from here, which is after t, so we get yt. This is the value. And for the last part, the plotting of y. So what we do is we combine all 3 parts of y together. So this is the first part of y from case 1. This is the second part of y from case 2. And this is the third part of y from case 3. And that is how we do a convolution using graphical method. So the integration can also be done in a different way, which is using this yt equals to xt convolute ht, where x becomes t minus tau. But I did not use this equation because x did not have an x was not given a value there, but h was given a value. Right, h had a piecewise function value, so it is easier to do it through ht instead of x function. That is my understanding. So that's it from me today. Thank you and goodbye.